verify what we have done up to now. We have found a minimal function realization by using Kuhn-McCluskey method and the Carnot method. So in there we have found a minimal function realization. Minimal function realization, is this the ideal realization? We cannot say that. Why is that? Because there was a limitation while we are defining this minimal function. We said first canonical type minimal function and or type of elements included minimal function. We didn't consider the other types. For example, exclusive OR type memory elements has gates haven't been considered. So that's one limitation. The other limitation is AND/OR type realization is a two-level realization. Can we say that always two-level realization is much better than the higher level realization? We cannot say that. Why we cannot say that? Assume that you are designing a subcircuit and there are some other subcircuits in your design. If because of the other subcircuits response time or propagation delay time is high, let's say. So if you design a subcircuit which has the subcircuit that you are dealing with, if you say that this subcircuit must be as fast as possible, that means delay time is minimal. Due to the other subcircuits, you don't need that. When you make it fast, still, due to the other subcircuits, you're going to wait to observe the output. So make it a faster subcircuit design. In some cases, wouldn't be the ideal case. So this explanation tells me, in some cases, I might use multi-level realizations. Not two-level, but multi-level. So in minimal function realization is two-level realization. So if there is a multi-level realization which includes less number of gates than the two-level realization, minimal function realization, then multi-level realization is better than the other one. So it's not the ideal. So which one is ideal, you cannot say that. Depends on the special situations that we are in. And one more thing is the XOR gate. We are not using XOR gate in two-level realization or AND/OR or AND type canonical form realization. We don't use XOR gate, but we know that XOR gate is available in the market. Therefore, it is not the ideal. We should say that the ideal case should be something like that. We should consider all the available gates within the market and then say minimal components included circuit I am going to design. So not easy to define a minimal function for these gates only. All the available gates. Not easy to define the minimal function, so it becomes a problem. But I can give you a counter example when this XOR gate becomes very critical. So look at this example here. That is the given function to us. You see there is a 1 here, there is a 0 here. If I move that 1 to this side, it becomes very low cost function, isn't it? So moving this one or replacing this one with that 0, it is called min-term interchange. If you do this min-term interchange, this operation becomes an XOR operation. So consider these two functions now. If you exclusive OR those two functions, you get the original function. So easy to say that. For example, for this, apart from this one, for the other ones, the corresponding cells have got 0 value. exclusive OR of 1 and 0 gives you 0, it gives you 1, isn't it? Exclusive OR, if one variable has got 1 value, the other variable has got 0 value, the result of the exclusive OR is going to be 1. So that means I show you now, for those ones with these zeros is going to give us all these ones here. This one and this one, the corresponding cells, when both of them 1, so exclusive OR result is 0. So if you look at this one and this one, this is 1, that is 0. They are different, so it becomes 1 here. So what I showed to you, this function can be written as this function exclusive OR with this function. Then if we design this function, which is equal to this one, third order subcube, it is just one variable. And this function here, it is an AND gate with 3 inputs. So it is this gate. Exclusive OR those two gives you that function. So at home, you could find the minimal function for this kernel map and compare it with this circuit. You're going to see it, cost is going to be much higher than this one. So this is how beneficial that exclusive OR usage. In special cases, you cannot generalize it, cannot say that for all functions it is better than the other one. So because of that property, we cannot say that Kuhn-McCluskey method is the best realization method. You've got to consider the other methods, so we are not teaching all of those here, and they are useful in special cases. That's another point. So that's the end of this video then.